Testing. If you can hear me, just say so in the chat. We'll start in about 5 minutes. Just say hi. I'm just testing that everything's working. That's not closing. Testing. Just make sure you can hear me. If you need me to make it louder or softer, let me know and I can change it. Or if there's too much noise or anything. Can everyone hear me clearly? Am I too quiet or too loud? Seems to be fine. Sounds all right. Cool. All right, so close that. Move that there. That. Awesome. Okay, so welcome to the running out of room. Welcome to the very first PES live stream for 2019. The way this works is if you've got a question, put it on the chat. If you understood something that I've said, just say okay, yes, something like that. Just some kind of feedback. It makes it so much easier to do when you get some feedback happening. So if you understood it, say yes. If you didn't understand it, say no. And I've got a couple of things that we can start with, unless anyone's got any questions. So what I planned to do is look at next week's lab, have a look at some of the things that are inside it and break them down piece by piece. And then we'll go and have a look at the assignment and have a look at the structure of the assignment and give you a direction to go. And then we can next week, weekend, have a look at that in more detail once we've covered a little bit more of the content. So let's start off with the lab. So I'm just going to copy this sheet here. Do this. there. All right. So we'll be doing this all on PowerPoint, which is not PowerPoint, Photoshop, which is basically my virtual whiteboard. Now, sometimes we'll move to Notepad++. There's some things I can't show you because I can't connect to the server while doing this, because it'd make this incredibly slow. But we'll try and make do, and I've got some other software that we can use in the meantime. All right, so next week's lab, the very first task is much a walkthrough, and we'll guide you along the way. But if you can follow this, it follows the same structure that we're going to do pretty much every week. So the very first thing is that we're going to write this multi-line comment. So in C, we've got two different types of comments. We've got, what am I doing? We've got /* and then a */, which is a multi-line comment. And we've got a // which is a single line comment. Cool. Now, with this multi-line, you can write lots and lots of lines until you want to stop. Yeah. For a single line, you just write it after. Now, really, if you wanted to, you can replace all multi-lines with just multiple single lines. The single lines are good because you can add them at the end of a line. So, for example, if I have int a is 4, I can add a comment after that explaining it, especially if it's a complex equation or something like that. So I think most of you understand comments, but what I find most students do poorly is using the actual comments. So with your comments, one bit of advice is remember that the people reading your code already know C, but they don't know what the problem it is that you're solving or how you're solving it, okay? For example, I can give you a bunch of maths and you understand all the symbols, but you don't know what it solves. So with your comments, just make sure that you are explaining it to someone that understands C, but doesn't understand what you're doing or what the purpose of the lab assignment piece of work that you're working on is. So basically each week, try and put a little description. This will also help you. Sometimes it can be a bit overwhelming when you get into week 8 and you go back and have a look at your work and you're like, I don't know what I did then. I'm not as good as I am now. And so it's all looking a bit ugly. All right, so does everyone have a good understanding of comments? Is there anything you want me to go over with comments? If you understand comments, just say yes or sure or thumbs up in the chat, and then we'll move on to the next thing. Good. Used to overlay the instructions. The instructions is just copied from my screen. Sure. All right. The next thing we've got here is this hash include standard.io.h. So the first thing that you'll notice with C is that without standard.io, it actually doesn't have that much functionality. For example, trying to print to the screen would require a huge amount of work without this standard.io, okay? We only get access to the basic things in C without this standard.io, okay? So standard.io stands for standard input and output, okay? So this includes all the stuff you want to print to the screen or to a file, okay? So stuff you want to print to the screen or to a file, or stuff you want to get from the keyboard or from a file. Okay? So we'll look at files later, but you'll find that when you get to files, they will act exactly like the keyboard and screen. Okay? Because we're using this same library, other than having to specify the file, they will act very, very similar. Yeah? Yes, but by the screen, I'm in the console. Okay, I'm just using a simplified description. And what you'll actually find later on is that the screen or console is actually just a file. Okay, and same with the keyboard. So with this, what we need to also have a look at is the fact that this gives us access to things like printf, scanf, getChar, and a range of other functions that you're going to be introduced to. Now, these functions have functionality. So this adds functionality to your program that by using C alone, you wouldn't have, or you'd have to implement yourself, which is very difficult, especially at this stage. So this printf prints to the screen. The F stands for formatted, not function. A lot of people fall for that. Same with scan formatted and getChar, which gets a single character. Okay. So with our functions, they sometimes require information. They sometimes give us information back. And sometimes they won't give us anything back. Okay? So printf is a bit more interesting. So we can give it one to many arguments. Okay? And the arguments are the things that are in the brackets. Okay? And the number of arguments is separated by a comma. Now, for most of the stuff that you'll be doing in this subject, especially when you write your own functions, you'll know how many arguments there are. But printf allows many because it depends upon how many format specifiers you have. Okay? The same applies with scanf. It can have many arguments. Okay? Now, printf and scanf also do return some information. Printf returns the number of characters printed, and scanf returns the number of characters read. Okay, so you can actually do something like this. Okay, and this used to be a challenge question that we used to ask in this class. Okay, so if you want to see how many characters were actually printed, you can store that value. Now, when you return something from a function, it's completely optional if you want to store it or not. Okay, so the function says, I've got some information for you. If you'd like it, you can have it. If you don't, just ignore it. So by ignoring it, we just write printf on a line, and we don't use any assignment whatsoever. And this is what we do 99% of the time with printf. Okay, so unless you want to try that out, and you can try that out for yourself and see what happens if you make the words longer or shorter or the numbers longer and shorter. But most of the time, we actually ignore what's returned. getChar is a little bit different. So getChar's a very direct function. It's saying, get the character. I don't need any information from you, just get the character. Okay, so if I require no information, these brackets will be empty and nothing comes in. But we get something out. Now, with this, if on a line we write getChar and we don't store the value, then we're just ignoring what we get back. Okay, and we lose that information. So sometimes you will need to store the value returned from a function. Not an int, we'll use a car because we're getting a car. Yeah. So this is the basics of what standard I/O provides us. It provides us an interface to get stuff from the screen and, print stuff to the screen and get stuff from the keyboard. Now, with this, standard I/O, you should always double check that you have spelt this correctly at the start. And the way you do that is to compile right from the start before you start writing things. Okay. If you don't do this, then you're going to have problems every single place that you've called a function that's from standard I/O. And with this, when you start off, all it does is it will try and find this library. And if it can't find it, then it'll let you know. And this is why it's important. As soon as we've got the basic template up, we compile because we want to test all of these parts. At this stage, you're only going to have one, which is standard I/O. But later in the subject, you might have up to 4 different includes. Okay. All right, let me just check. All right, so for those that are joining late, now they're not going to hear this, but they might hear it when they reach it. Just skip ahead, so then you'll be up to the speed with everyone that's in the chat. All right. Don't want to do that. They're on the same layer. Right down. All right. I'll put that on another layer. Cool. All right. We then have a comment after the include, just explaining what it is. Okay. So is everyone okay up to step 4? People that we got here. Yeah. So if you're okay up to step 4, just say yes in the chat or no or thumbs up or something similar. We'll keep going on and we'll get to the harder parts. That's awesome. Awesome stuff. Okay. So next we get to because we're on the wrong layer. That would help. All right, next we get to step 5, which is adding the main function, which we also call as the entry point function. Basically, whenever your code starts, this is where it's going to start. Okay. This is also a function. Now, we haven't covered functions in depth yet, and I'm not expecting you to have to understand what this int is up here yet. But if you have done a bit of C before, this int is required with our ANSI C. We're also going to add, right from the start, a return 0. Okay. Now, whilst you haven't done functions yet, you can kind of get an idea of what this means. Basically, if we get through all our code and reach this point, then it's done. But we can't see that. So we let Unix know that we're done by returning a 0 back to Unix. All right. Now, we're not going to use that till a lot later in the subject, but the basic practice is just before your last brace, you return 0. Okay? Does it return 0 by default? No. It could return anything. So yes, we need to specify 0 because it could actually return anything. It's just going to grab something random. Now, the other thing, no, you don't need math.h in the second task. Do you? If you want to use math.h, you can. You don't need it. Now, the other thing is that you'll note that all the code is indented. This means whenever we have a brace, we move in one tab. When we have a closing brace, we move back one tab. Now, this is called Allman style, where we have the brace after the function's signature. And you may see another style online where the brace is up here. That's not the style we're using. Okay, we're using the Allman style, so the braces should line up with each other. So a good thing to check when you're coding is just double check that there's nothing on that line between two braces. Everything should be one tab, and if you've got more braces, it's going to move in. And so you should see some hills and valleys in your code that look something like this, based on where all the braces are. Okay? And this actually, for someone reading it, really helps understand what's happening in your code and what's actually related. Allman. Not sure what you're asking. Allman. The style diagram is, I think I've spelled it correctly. If you go to your resources and you go down to the bottom, you can get the Wikipedia page on the style as well. Okay, it's called the Allman style, and you can see how it's done below. Cool. So is everyone okay up to there? Let me go copy the next part. So if you're fine up to there, just say okay, and we can get through this stuff quickly. If not, then we can go through it a bit slower. We've got plenty of time, so don't stress. So if you're okay with that, just say okay in the chat while I get this next part over. All right, let me put the layer on. Cool. All right, so let's get rid of that. That's layer 2. Cool. All right. So, give me 2 seconds. On the right layer. You need to use typecasting in steps 17, which means go back to step 15 and fix it. So we can talk about that in a little bit. All right, so what we got pen, beautiful. All right, so add the statements to print some text to the user as follows. So this program will demonstrate the use of types and printf in C programs. Now, one thing that you'll notice here is that C programs, so let me actually write the whole thing. So we've got printf, then we've got and printf in, and then I've got slash and then quotation marks, and then C programs, and then slash quotation marks, and then a slash n, and then that finishes. Okay. Now, this is important. There are some characters that we can't directly write into our printfs. And we've seen a couple of them, like the slash n, but there are other ones like our double quotes and our single quotes that we can't write directly, because if we wrote a double quote here, it'd think that the string has finished here. Okay, the text is finished here. So we have to escape it and put the double quotes there. The line won't be printed. Okay, so this will print and printf in C programs. Okay, it won't print the line, it'll print the quote. If you don't include this, you would have got an error. Okay, because it doesn't know where this bit of text ends. Okay. Another common one is that if you need a slash somewhere in here, you have to write 2 slashes to get 1. Okay. So if I wanted to put a slash after the in, I'd have to write 2 of those. Okay. And that would print 1. All right. Now, the other one that gets a lot of students, if I want to print the % symbol, okay, then I write %, and that will print out 1% symbol. Okay, because if I just put this by itself, it'll think that there's going to be a format specifier coming after it. It's going to think that there's going to be a D or an F or something. And to make it actually print a % symbol, we write %, and that'll print 1% symbol. So that's something you can test yourself if you want to try it out. And I think they're in the reference sheet as well, so I might pull that up. Second. Too many windows open. No, it's not slash. It kind of breaks the convention. It's a little bit odd, but so they're your escape. They're the basic escape sequences. So you've got your backslash, your single quotation, your double quotation. But where is it? Up here, you'll see that 2% prints %. It is really an escape sequence. It's not a format specifier, but that's how it was implemented. And so that's what we have to follow. All right. Then what have we got after that? Okay, so the next thing is, firstly, make sure you compile as you're going. I think we're all pretty clear on that at this stage. All right, next thing we have is int a. Okay, now I'm assuming that you watched some of the videos from last week, so I'll go through this pretty quickly. But if anyone doesn't understand, we can go through it a bit slowly. So A is the identifier and int is the type. And this is declaration without initialization. Now in C, when we declare a variable and we don't give it a value, it could be any value. Okay, it's not going to be 0. It may be 0 because a lot of memory is actually a lot of zeros if you actually go search through it, but it could be any value. Okay, and if I try and do something like int b becomes a plus 2, you'll get a warning, not an error. You'll get a warning saying uninitialized variable used in line blah, blah, blah. Okay, it's telling you that this value here is garbage. It should not be used as a random number, okay, either, okay, because it's not truly random, all right? It's going to be a value that you don't know beforehand, but it's based on whatever's in memory beforehand, okay? So if you've got int a, and then you go and print that out, okay, it says the variable a is of type int and has the value %d, that should print out a uninitialized. And you would have got a warning when you do that. And when you get to that stage, it'd be a great little experiment to go compare with your friends. What did they get when they printed it out? Some of you will get lots of zeros. Some of you will get very different numbers. Okay. So that's the purpose of this part here, is to have a look what happens when things are uninitialized and what that warning means. Because obviously, if you've got an uninitialized variable in a complex equation, it's never going to work. So here, what we do in step 10 is actually give it an initial value. So this is called initialization. So it means that we're guaranteed right from the start that a is 5. Okay, and the variable a is of type int and has the value %d, and we print out that 5. And guaranteed, as long as everyone implemented it correctly, you can go around the whole room and everyone will have 5. Okay, does that make sense, the initialization part? Just say yes, no, maybe. Maybe not maybe, but no or yes. Cool, cool, cool. So everyone's understanding up to here. All right, so next we have a look at a floating point value and another integer value. This is something that really confuses a lot of students early on. We're not actually looking at it in this one, but I've seen students, and it's a very basic concept. And there's a good video on this for next week's, which is literals in different bases. Car is an integer type, okay? Don't get confused by that. It does store a value. You're not going to explore that this week, but when you get a chance, watch that video and understand why car is an integer type. If you have watched it and you still don't understand why, I can put a more detailed, or we can go over it next week in a little bit more detail, because that's a really important concept that if you understand that from the start, you'll understand why we can store different literals in different ways. Now, the other thing is, and I've seen a lot of students do this in like week 12, I'll ask them what's a literal and they still won't know. So we have int a is 5 here. This is the variable, okay? This is the literal, okay? The reason that this is a literal is that it's literally 5, okay? It's not 6, it's not 4, it's 5. It can't be any other value because I've literally specified it as 5. A, on the other hand, can be 1, it can be 2, it can be 7, it can be 400, it can be any value. It's a variable, it changes. But the literal here, 5 cannot be 4. Okay, 5 cannot be 7. 5 cannot be 2. It's literally 5. And that's why it's called a literal. Now, this might get a bit confusing because you've probably done mathematics and you've heard of constants. Constants have a slightly different meaning in C, which we'll see later in this subject. And we'll get to that later. Okay, I'm not going to confuse you by that because it's actually a little bit harder. So we won't be touching constants for quite a while. So just be careful of your terminology. These are called literals. And the same with this, it's literally T. The little quotation marks say that it's a single character T. The double quotes that we've seen already, don't stress about these too much. The concept here is actually a little bit more difficult than we're presenting. And we'll see this in about week 5 or 6, what's actually happening here. But the single characters, it's just getting the character and converting it to its ASCII value. And then you've got 5.5, which is literally 5.5. Okay, so that's the definition of a literal. Just make sure that you understand that terminology. Yes, you call it a string literal. Yeah, so this here is a string literal because it's the string hello and it can't possibly be the string goodbye. So this is called a string literal. Okay, we're going to have strings later that will be variable, but that there, if we specify it directly, anything specified directly, on that line, it can't possibly be any other value. Okay? We will have strings that can change, but hello here can't change. Okay? There's nothing in the code that can insert other code to make that change. Okay? That might not make much sense right now, but wait until a couple of weeks and it'll make a bit more sense. We don't do much string stuff in the labs, but we're going to do similar stuff with other data types, more scientific data types. All right. Another thing that is here is that one of the arguments to the function is an expression. Don't be afraid to do that. I see a lot of students be a little bit afraid to do that. So you can put an expression here. All it will do, it will calculate it first and then send the value to the function. Okay, so that is something you can do. You've seen it a couple of times already in the practice lab, and you'll see it in this one. So that's the start. We then get to the interesting part. Now, there is a half-an-hour video on this, and I would highly recommend you watch that when you get a chance. We'll do the quick and dirty version of this right now. But if you understand types, then and how they're evaluated, it will make when we get to memory a lot easier later. So when you've got a spare half an hour, just sit down and watch that video because it will be very, very helpful. But let's look at the quick version of it to save everyone a bit of time, especially if you've already watched it. So here we have, what's B? B's a float. So we've got float, B is 5.5, and we've got A, which is 5, and we've got D. Actually, I'll change the values a little bit so that it's a different question than yours. So I'm going to make float B, say 10.2. Let's make A 2. Oh, yeah, let's make it 2. And D 4. Okay. So you can see the result of yours, which will be different. I don't want to ruin the surprise for you. All right, so here we have B. Now, I'll talk about this symbol in a second. So first things first, a bit of terminology, and it can be difficult, and we understand it, and it's difficult for us as well. For myself, who's switching constantly between mathematics and coding, we accidentally say equals. It's not equals though. It's assigns or assign the value of. The word that I like to use, because I think it flows better off the tongue, is becomes. So B becomes the result of this. Feel free to use that terminology. That's the terminology that I've used for a very long time. And I think it helps some students understand what's happening a little better because it's more a word that they're used to rather than assigns. Okay, so what we're basically saying here is B becomes whatever value this results as. Okay, as simple or as complex as it may be. Okay, so I can say something like B becomes 4, or I can say B becomes the addition of A plus 2. Okay, so if you find that a bit easier, feel free to use becomes. That's what I tend to use. All right, now here we've got a bit of a problem. So here we've got 10.2 plus 2 divided by 4. Now, the expected result would be what? Put it in the chat. What would the expected result be? Okay, so the expected result would be 10.7. Okay, now if you were doing a test, and we'll get to black box and white box testing in week 11, that would be what you want. Okay, that would be your expected result. But when calculating this and actually going and printing this out, we only get 10.2. Now, this is because of the way that computers handle types and also handle computation. So we've got different units on the computer which will basically do our arithmetic, and floating point arithmetic is done differently than integer arithmetic, and it requires different hardware. And the reason for that is because floating point is actually quite slow. And so the computer tries to speed this up where it possibly can and always try and use integer arithmetic where it can. So we'll have a look at this and we'll have a look what's happening and we will see. So a representation that I also use is uppercase types. So uppercase I for integer types and uppercase F for floating point types. Now, usually when I do this, because I don't really care if they're short, cars, longs, I'll just represent all of them by int. And I don't care if they're doubles or floats, so I'll represent them all by floats. This is not code, it's just a representation to understand what's happening. Okay, so you wouldn't write this literally. So B is a floating point type. A is an integer type divided by an integer type. Now, with our arithmetic, we need to think about our order of operations. Okay, So we need to think about our order of operations here. Now, our division has a higher precedence here. Okay? So because our division has a higher precedence, this is going to be calculated first. Now, for most of this first half of the subject, this is where most of your problems are going to occur with integers and floats and the difference between the two. Okay, and this is called integer division. Okay, we will see some later cases later in this subject where we need typecasting for other reasons, but for the start of this subject, pretty much all of your problems with typecasting are going to involve integer division. So here we have an int divided by an int. Now, when the computer processes this, the division is passed through an integer division because the larger of the two types is an integer. So they both are converted into an integer and passed through that division. So we get an integer out. Now, an integer can't hold the information a floating point number can. Okay? It doesn't have a mantissa. Okay, so it doesn't have a dot and some value following it. And so what we get is a value that's truncated such that 2 divided by 4 would give us 0. Okay. We then get to the next step, which is a floating point plus an integer. Now, with any arithmetic operator, the types will be converted up to the largest type of the two. So this integer would actually be promoted to a floating point, and we get a 0.0 plus our 10.2. Because we're doing floating point addition, we get a floating point out, and so we get 10.2. Then, right at the end, we have b becomes 10.2. Now, b is an integer type, and on the right-hand side, we have a floating point type. So this needs to be converted. Oh, no, sorry, wrong way. I'm thinking of a different problem. All right, so on the left-hand side, we have a floating point. On the right-hand side, we have a floating point. Because we have that, we can just store it directly in. Okay. Now, what does this tell us? So it tells us a couple of things. It tells us basically whenever we have an integer divided by an integer, we can either do some cool tricks, okay, where we don't want to store whatever follows the decimal point, or it's going to cause us problems, okay, because we lose information. Okay, so you're going to see this in both ways. You're going to see this when we use this intentionally a little bit later, but right now it's causing us problems because we're not getting the value we wanted. So one way we could possibly fix this is multiplying by 1.0, which is one of the methods that I mentioned in my video. Now, this isn't a very good method, but you can see why in that video. I won't waste your time right now explaining that. All right, so what we're going to do instead is we're going to typecast. And the power of typecasting is actually more about its precedence. So if you have a look at the precedence table, okay, so this is like BODMAS, but a lot more difficult. You can see that your plus, minus, multiply, and divide are down here. So they've got priority 3 and 4. Well, your typecast has a lot higher priority, meaning that it will be activated first. Okay, doesn't matter how many pluses and minuses or how many multiplications and divisions, your typecast will come first. Now, there are things above it, so just be careful. All right, so we're going to apply a typecast, and we're going to do it. Let's do it 3 different ways, because there is one mistake that a lot of students make when doing typecasting on divisions. So we'll go through that mistake, and we'll try and do this fairly quickly because there is a whole video on it. I don't want to bore you too much. So the first typecast is going to be this one here. So all this says here is that we've got a float plus a typecast float with an integer divided by an integer. Now, in terms of order of operation, the operation between these two happens first, the division happens second, and the addition happens third. Okay? Remembering that our typecast has the highest precedence compared to a division and an addition. So because of that, what it does to A is basically it promotes it to a floating point type. So we get a new expression that will look something like this. Now, someone asked a really good question a little while ago. Do I have to write all these steps out in my code? And the answer is no. This is what the computer's doing. Okay, so just understand that what I'm doing here is what the computer's doing. Okay, so you don't have to do this manually yourself. Now, the fact that I change this into a float means that now, when I go and do this division, the largest of the two types is a float. So they both need to be a float before we can do floating point division. So the integer gets promoted to a float, and then the result is a float. And we'd get the correct answer. Okay. Now, the other way that we could have done this is put the float on the denominator, sorry. So we've got float there, float here. And this would work just as well because the D would be promoted to a float, and we have at least one float in the division. The mistake that I see some students do is the following. Okay, so this is a common mistake that I see, and we've introduced something new here. We've actually introduced another operator, which is our brackets. And our brackets are this sub-expression, okay? Right? And we are going to see that that's right up the top, okay? So that we've got this sub-expression. Sorry. So with typecast, sorry. So if you don't know what a typecast is, I can go over that as well. So as I said, there is a half-an-hour video on it. I assumed most had watched it, but that's fine. We can cover that as well. All right. So I'll come back to the question. But basically here, because of these brackets, this is going to be done first, then the typecast, then the addition. And because of that, we still have integer division, okay? Because we have int divided by an int. The float is on the outside. So we actually calculate that and then convert the result to a float. So we're just turning the 0 into 0.0. All right. So for the person that asked what a typecast is, basically what we're doing is it's a unary operator, so meaning it acts on one thing, and it basically you get brackets, and inside you write a type. Next to it should be a variable. So for example, A, and what it'll do is it will change whatever value is here. It also can be a literal, but it's kind of pointless. It'll change the value here into that type, either casting up, okay, or casting down. Now, I won't go into the details of casting up and casting down. As I said, there's a long video on that. But for now, you can think of it as if I've got this here, it converts A into a, well, it doesn't convert A, it converts the value in A into a float. So A is 2, okay? So the result of this would convert it into a floating point number. Okay. So in terms of literals, it's really redundant putting a typecast in front of them because you can specify a literal as its type. And if you go to the reference sheet, there's pretty much a comprehensive list of all of the literals. I'm pretty sure I put it in here somewhere. Maybe I didn't. Where did I put it? Literals. There. Oh, here we go. Literals. So you can specify the type. So you can specify you want it as a float by putting the F at the end. This is going to be a lot quicker than actually applying a typecast. Okay. So you can do it if you really want, but it is redundant. I shouldn't have closed that. Oh well. I can reopen that. All right. So that gets us to our typecasting, and that gets us to the end of that lab. So from here, I will make some mentions of some things in the second lab very shortly, and then we'll go on to the assignment. I'm not going to give away. So as I've said, each week, the second task is meant to be the problem-solving task, so I don't want to give too much away. But if there is something in there specifically, feel free to ask a question. We can discuss it in a bit more depth. But I will talk about a couple of things. I'm just going to take a 5-minute break. So we'll be back at 6. All right. I'll be back in probably less than 5, but about 5. Great. Thanks for the person who pointed that out. Audio definitely helps. So I was just saying that there's no PDF or Word document submissions this year. In previous years, we got to write reports. This year, we don't have that. So don't worry about the PDF Word. You just submit the source code. Same with the assignments. We don't do, if you've done this subject in the past, there's no reports anymore. Rather, we're going to be looking at the documentation in the code, as we found that works better. So the second task is a little bit more challenging. It gives you the steps, but you might need to modify them to get things to work perfectly. And I'll talk to you about that. The other thing is, don't forget this part here. Let me just grab one other thing, which is the rubric. So this year we've got a nice simple rubric, but you need to read it because it does include certain things. So the important thing here is if you want full marks, you need a unique, suitable comment describing the problem at the top of the code. Okay, variables named suitably. Okay, it gives you the names. So if you go and change everything to PO and PI and DO, then you're just doing it to yourself. Okay. Same with the second ones. Names are important. Values correct are important as well. Okay. Why did I do that? All right. So it needs to be in. It needs to be your own words. So just you can take what's there and just write it or paraphrase it in your own words. All right. How do you submit source code on LMS? So that's an excellent question. Let me get it up. LMS. Right. So I'm just going to answer this question because it's a really important question, is how to submit your source code. So not LMS. It's just on another page. I'll just get it up there. All right. It's not LMS. All right. So we've got LMS. When it comes to submitting, you go to week 3. You'll go down and you'll find this Lab 1 Bandura submissions. Now, there's 2 rules that you have to. There's 2 rules that you must follow to be able to submit. The first one is that you have done at least 1 attempt of the week 2 quiz, and the other is that it needs to be 1 hour. So it needs to be before 1 hour after your allocated lab. Now yours is going to look a lot simpler than this because you don't have to worry about everyone's submissions, but you can double check the calendar and on the side it'll say when you have to submit. Okay. Does that make sense on how to submit? It's just a submission here. And once you click on it, you can go in, and down the bottom it'll have add submission. Is that clear, or is there something you can't see? Because I really want to know. Okay, cool. All right, cool. And obviously you can't grade. All right. So can you name the variables? Other welcome to, as long as they're relevant and are suitable. Now, one thing that this question, there's 2 traps in this question that add the problem solving part. The first part is that you have to convert to millipascals. Okay, so I will let you work that out. If you have a bit of trouble, we can give you some hints in the lab. And the other one is a little bit more hidden. And so I'll give you an example, and then from there, you can work off that. Can you explain how to set up on Linux system? So I'll come back to that as well. All right, so before I'll come back to your question about Linux in a second. So this is a quick example. Let's go Z. Help if I could draw a straight line. Divided by C times D times Z. So it's A times B, C times D. Now, the problem that arises with floating point arithmetic is that multiplications and divisions can introduce error because you're multiplying. The error of the fact that they can only store a finite number of decimal places. If you actually have a look at the type, you can see how it's stored and why it's finite. Okay, you've got a mantissa and an exponent. That doesn't really matter too much for this subject, but what you should understand is that when you've got floating point numbers and you've got multiplication, the less multiplication, the less error. Okay. So if we can get rid of some multiplication, that's very handy. And so usually when solving scientific problems using code, before even coding, we'll get the formulas and try and simplify them down to make less calculations so that we have less error introduced. This one here versus this one here, we've cancelled out the Z, okay? So this one should have either equal or less than error than the one above, okay? So if you find that your values don't come out exactly as the sample, okay? So if it's meant to be 50 and you get 49 instead, go back and have a look at the math and see if you can cancel some things out such that you can get this. The other thing is that in this question, it doesn't really change the accuracy or anything like that, but you can do the whole thing without typecasting, okay? Without changing the types, okay? So you need to keep the types the same. That you can't change, but given the types, you can actually do it without typecasting. Yeah, you should be able to. So that's that question. It's once again, it's only the first week of marked labs, so it's not overly complex and shouldn't cause you too much troubles. But you do need to go have a look at the maths and see, can I cancel anything out? And also, let's go have a look at my scientific prefixes and see how that cancels out. All right. In terms of the question about setting up from Linux, basically, with Linux, you can follow the Mac guide in terms of SSHing. And then for an editor, you can use Atom like on the Mac as well. I haven't tried setting up the FTP on Linux. I usually use an editor like Vim. If you're using Linux, I'm assuming you use Vim. And if you use Vim, then you can just SSH and use Vim. If you're not sure, come to one of the labs that I'm in and we can work it out. It's a bit hard explaining it here, especially on this machine. Okay, but I've got Linux on my laptop, so we can go through it together. All right, is that all making sense so far? If it is, say yes, put a smiley face, put a whatever face. If it's not, and you've got more questions, ask the questions while I get the assignment specification. How many people have we got? 22, that's not bad. Awesome. Awesome stuff. All right, so let's go through the assignment specifications. The first thing that I want to do is just have a look at the assignment specification because there's a lot of stuff there. And the reason for there being a lot of stuff there is firstly for us to stop plagiarism and all these little bits and pieces. And the other reason is to make sure that it's a fair playing field so that students starting from nothing have the same chance as students starting with a lot of previous knowledge. And one thing I do recommend is if you have done a bit of C before, make sure you read over the lectures because a lot of students that have done it before do strange things in their assignments. All right, so blah, 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 blah. We don't need all that. So you only need to submit the C file. We don't need the executable. It doesn't help us at all. We just need the C file. So that's that. With the submissions, I've lost LMS again. With the submissions on LMS, you do need to go through a portal which will, here we go. So I'll get the submissions up before we do that. So it's really clear where everything is. So with the assignments, it's a two-stage process. The first thing you need to do is go to this agreement. Okay? And with this, read it, okay? And make sure that you have done this stuff. If you haven't done this, get in contact. And then sign it, okay, by saying I agree and then finish the attempt. This will unlock the submission portal, okay? So keep in mind that you are signing this. Make sure you have read this. This is really important. From here, this will be available, okay? And then it's just like the other submissions. You just go down the bottom, add submission. Okay. Now, with this submissions, you can submit as many times as you like. Okay. And so what I recommend you do is after you do a session of working, just submit whatever you've got. Okay. Even if it doesn't work, it doesn't run, it's broken, whatever, just submit whatever you've got and just keep overwriting your submission. It means two things. So firstly, it's a backup if something breaks down. And secondly, if you forget to submit your assignment, let's say you sleep in or something happens, at least something is there. Okay? The assignment submission, the due date's there. Due 31st of March, 2019, 10 p.m. The second one I haven't decided on yet, but that's the due date for this one. Okay. If we move that or extend that, we'll let you know. Okay, but I'll remind everyone about this in the lab this week. not mean to do that. Okay. Yes. Let me get the other thing back up. All right. So yes, it needs to be the source. We don't want the executable. The executable means nothing to us. We can't mark an executable. Do not submit anything other than the .c file. And submit that often, and that will really help. The other thing is that I'm occasionally checking the submissions. I'm not guaranteeing that, but I do like to have a look at and see where people are up to and who's doing really well and who needs a bit more help. And because of that, if you've got something that's weird or you accidentally sent a text file rather than a C file, I can let you know if you are submitting often. So there's that as well. There's no late submission, okay? So be aware of that. This is the background information. I think the math here is fairly self-explanatory. If you are unsure on the maths, just let me know and we can go through it. But I think that math there is kind of good. You've got the problem statement at the top, and then you've got the steps that follow through. And we can go through those in a second, but let's go through the other important parts. So it's the user that selects the resolution, not the programmer. Formatting needs to be as specified, so please don't add extra stuff in there. Don't say, hi, how's your day? Welcome to my program, or goodbye. We don't need that. And if you were to get a brief, you should follow the official specification. All right, we can come back to that. Cool. Text needs to be easily understandable. You can change the text in terms of the prompts, as long as they don't. So with the text, just don't put extra new lines. So for example, for this here, if you change this to, can you please select the table you'd like to create? I wouldn't have a problem with that. It won't wreck our test cases or anything like that. But if you put this over multiple lines, it will. Okay. So feel free to change the text if you really want. You don't have to. You're not going to get any extra marks or anything. But just don't put extra new lines and stuff like that. The same inputs must be used. The program must print your student number, name, and assignment as specified. The program must print the password as specified. Types should be used appropriately. So with this, if it tells you the type, use that type. Generally, with C, you can, if you use an int where you need an integer, it's usually okay. And if you need a floating point, just use a float. Otherwise, if you know the value is going to be very small, then you can use other types or very large. All right, we'll come back to that. You don't need to use functions. If you use functions, you won't get any, and you won't lose any extra marks unless it doesn't work because of the functions. You must use comments to explain significant lines of code. We're testing what you know in this subject only. So if you've got stuff outside, you might lose marks in the stuff that we're looking for that's in the lectures. Okay, so just be aware of that. The code must be done using ANSI C and compile on our system. You cannot use goto anywhere in the assignment, and you're only allowed to include the standard io.h header. Don't use con.io. This line here is a hint. It's not to be taken completely literally. Some students got a bit confused by this. This just means if you're completely off track, it will help you know that by if you're 100 lines of code, you're doing it wrong. Solve the program by implementing a program using C code. The code must be documented using comments. Then you've got the marking guide. Okay. Uses of goto, no student number, no password, including header files outside of standard IO will lose you a ridiculous amount of marks. Now, the other thing here are expressions and concepts taught used appropriately. My advice there, if you're using break, I would highly recommend you reconsider the approach you're taking because you might lose marks here. Okay, there is no need for breaking this at all. Okay, and I'll do another video on why we try and avoid break sometime soon. But right now, that wasn't taught in the lectures nor the labs, and so it's not a concept that was taught. So if you are using break and it is inappropriate, we will take marks off there. Okay. So if you are using break, I just recommend trying to find a solution that doesn't. All right, now, the question that just got asked was an excellent question because it answers the first thing here. So number one, comment at the top of the file, the program's purpose and how the program is implemented. This should be in your own words. So this should be in your C file as a comment. So if you store the start of the live stream, we can have a multi-line comment. So you can just write /*/ and put all of that information here. Okay. Yes, I'm saying break. Okay. So for the first part, do write the program's purpose and implementation within C file. Yes, it's going to be within the C as a comment. Then you print your student number. Now, I know this seems simple, but do not write John Smith. I don't know how many times I have to say that, but it does happen. It's your name, okay, not the name that's here, okay? It's just a literal. You don't need format specifiers or anything special to print this out. It's just literally your student number and your name. Okay. Yes, it's pretty funny, but it happens. All right. Same thing with the password. It tells you exactly what to write. Just follow the instructions. We're not going to tell you why that's there, but you need to include it. Okay. And as we said, you will lose 100% of the assignment if you don't include it. All right. It's very simple. It's self-explanatory. It's literally just copy and paste whatever's written there, and it will work. Okay. You don't have to worry what it does. Just follow it. No, we're not discussing assignment 2 at this stage. We will have a very big discussion about that. Assignment 2, we can discuss in a couple, maybe 2 weeks' time, unless there's a lot of students that want to discuss it. But right now, I think this is probably more important. From there, you're going to print to the screen. This here is actually some concept that's really important, and a lot of students forget about it. C students seem to be better than Java students with this, so that's a good thing. When you want something from the user, you need to prompt them or ask them for it, okay? They're not going to know without you telling them, please enter a value or something like that, okay? So that's just, it might seem obvious, but I see a lot of students forget that, and they'll be looking at a black screen and not know what's going on. All right, so the program accepts an integer value entered by the user. Now here you see in the brackets, you can assume here that the user will always enter an integer value. We used to have a bonus task where they wouldn't, But we got rid of that so you can focus more on the problem solving and the steps. So you're guaranteed that they'll enter an integer value. And for this, it's any integer value. So if you decide to use car here or something, it won't be anything outside of that range. Okay. The test cases only look at small numbers like 55 and 22. Our test cases are different than this, but they'll be similar in size. Okay. Now, my advice here is when you get to this stage here, A, if the user does not enter the value 1 or 2, the program should print the following and reprint step 2. Now, if this is a little bit difficult, skip that step for now, because this is just an invalid case. So the program should work if the user enters all the correct stuff. So you can deal with these little things a little later if you want. Okay. But we'll talk about that in the help session in a bit more detail. If the user enters a 1, then you get a value from the user. Once again, all of these, you can assume that they're integers, and you can assume that the starting will be smaller than the ending. So you know what's going to be on our test cases in terms of we're not going to give you anything stupid that would break your code if it works correctly. Okay, so that's what all these blue things mean. So here we're just printing to the user and getting a value. So it's going to be lots of printfs and scanfs. The program accepts an integer value. Once again, it's a valid value, so we're not going to enter 102. Then you get to the printing of the table. Now, we haven't done this yet, so I can't talk too much about this, but this is where you're going to be looping. Okay? And with this, we're also going to use the format specifiers we learned last week, which include the width, which I think someone had a question on, which we can go through, and also the precision. Okay, now this here, please don't change the formatting on this. Make sure it's exactly as specified, including the spelling and everything. And then if the user enters a 2, we do this stuff, okay, which is very similar, which we're doing the conversion the other way. So let me answer the question about width first, and then we'll have a bit more of a breakdown and we can draw a bit of a... Okay, so someone just asked a question. So should we add code if the user enters 102 in the step size? No, you don't have to, because you can assume here that the user will always enter a valid value and an integer. So what you can imagine is that there's another layer to this that validates the inputs, so you always get a valid input. This won't be true with some of the assignments, but here, if you want to add it, you can. You're not going to get any extra marks. It's not something that we're looking for. We only need to see that you know how to validate once, and that's going to be up here. Okay, so doing this here, we've already seen you check and validate a value, so we don't need to see it again. So we're not going to make you retype it again. Okay. In other assignments, we will be there will be more things that you will have to add, but for these, you can assume that the values are valid. This is the ones that aren't valid. So, all right. So, first question is, do you have to use a do-while loop? So there is a couple of loops that you'll have to use in this. The choice of loops is kind of given. The 2 printing of the tables are for loops, and I actually write at the bottom hint for loop, which you can see here. The first loop isn't specified. And that's up to you. Now, there is a better way to do it. Your choice is either a while loop or a do while loop, and one is better than the other. Okay, and we can discuss that a little bit more depth when we get to that. But I might leave that for now. And if we have time, we can cover that as well. But someone asked about width. So what's the question about width? Because I think that's the simplest thing to address right now. With questions, I try and prioritize the simpler ones first, so that those students can follow along with the harder stuff as well. So can we get? You've got a question in printing width. What's the question? Is everyone okay up to this point? Yeah, I know this with the assignment. What's stuttering? Me stuttering? Or the video? So if it's me stuttering, I can't do much about that. But if it's the video, try and change the quality down to, say, 144p or 240p. So you should be able to just change the quality. If that doesn't work, you could put a little bit of a delay on the video, such that you just set it so that it's a minute before the current point, and that might help. Other than that, I'm not sure. This is the connection from my side seems to be good. All right, so how to print a width of 2. The minimum is 4, right? So if it's 2, I don't really get your question, but let's have a revision of width to kind of see if we can find the problem. So let's just have a look at width. For those that have done it before, you can follow along and answer the questions. So I'm just going to create 3 variables. Okay, 4, 42, and 420. And from here, what I'm going to do is I'm going to print using different widths. So, and you mentioned a width of 2. So printf, we can print different format specifiers, and how we do that is with our percent symbol. And we've got different options that we can put here. The last option is always the type, which is going to be an int in this case. I'm also going to put a new line so you can follow along with this question. And I'm going to put an A here. Now, with this, I'm going to make copy and paste of this. We'll do a couple of different versions. That would save us some time. Actually, we're going to, doesn't really matter. All right, so we're going to print A, B, and C out. Now, I'm not going to put anything there now. Just imagine that space is Not there. Oh, this is not going to work. All right, so I'm just going to move these up a bit, move me around a bit, and go from there. All right, so if I have, sorry guys. All right, so if I have something like this, when I go and print it to the screen, I should see 4, 42, and 420. Okay. From here, I can add a width, and that's the minimum number of characters to display. So we'll use 3 rather than 2 because 3 is a little bit. We can use 2 still. All right, we'll use 2, and then we can move to 3 a bit later. So I'm going to add 2 there. Now, minimum number of characters. If we have a look at this 4, how many characters does it take up? It only takes up 1. Okay, so that doesn't satisfy the minimum number of characters. And so what the format specifier will do, it will insert a space such that it takes up 2 characters. So it satisfies the minimum. If we have a look at this 42, how many characters does this take up? 2. So it already satisfies the minimum. And if we have a look at this last one, we've got 3. Is 3 greater than the minimum? Yes, so it already satisfies it. So we can have a look at another example where we change this to, let's say, 3. Here, when we print the 4, once again, the 4 only takes up 1 character. But we need the minimum to be 3. Okay? The width specifies the minimum width. So here, we need to insert 2 spaces. Or we let printf insert 2 spaces such that we get a 4. Now, that minimum width of 3 is satisfied. If we have a look at this second line, 42 only takes up 2 characters. It doesn't satisfy this 3 here. So we have to insert another space such that we get 42. Okay. If we have a look at this last one, it takes up 3 spaces, which satisfies the minimum of 3. Does that make sense? So printing width of 2, you write 2 there. Okay? Printing a width of 3 puts a 3 there. The minimum width will be whatever you've written there. So cool. Awesome. Now there's another question about the assignments. Cool. Did you sort out the stuttering problem? Or is it still a problem? All right, where's the assignment? Is that the assignment? Yeah, that's the assignment. All right. So what I'll do is I'll move me over there. So, yeah. So, all right, cool. So I'm not going to worry about step 8 and step 11. And start. Isn't there a minimum 4 for the width? don't understand your question. The width is specified by whatever you write. If I write 4, then the minimum is 4. If I write 5, the minimum is 5. If I write 6, the minimum is 6. If I write 2, the minimum is 2. The example that I probably gave in the lab was 4, so the minimum would have been 4. If I wrote 10, then the minimum would have been 10. If I wrote 100, then the minimum would be 100. Whatever you specify as that width is the minimum. And there's an example in the reference sheet. I think I've lost the reference sheet, but if you're still not sure, I can show you where to find that. All right, so turn off this all. Okay. And that's the step size. Okay. Cool. All right, so let's just have a look at this program and start understanding what's happening. I'm not going to worry too much about the loops right now, but you can start drawing out the code and see the structure of it. Okay, I'll come back to that question about precision. Actually, so I got a question. We'll do that question first because that's a nice quick one. Precision, you just put a dot and then the number of decimal places you want. So for example, %.3f will print out a number with 3 decimal places. And that's precision. You can still put a width in there if you like or other flags, but that's precision. In regards to precision with strings, don't worry about it. We're not going to use it and it's not very useful. Okay, so precision is just dot and then the number, and that will print out the number of decimal places. All right, so let's have a look at this. All right, so let's see the structure of our program. So green, because comments are green naturally. So at the top, you're going to have some description. Okay. Then after that, you should have your hash include standard IO.h. Okay, so don't forget that. From here, you should have your main, and right at the bottom, you'll have return 0. Okay. At this stage, you should compile and double check that it works, and then go on to your first printf, which will print your name. From there, you'll have another printf, which will be around the password, which you need to follow that link on LMS. From there, you should have a couple more printfs, maybe 1 or 2, to do step number 4. I'm confused. Width is the number of characters to display on the screen. Precision is the number of decimal places. See if you can put your question into an example, and then we can go through the example. So see if you can pick something from the lab or something, and then we can go through the example on what you're stuck on. All right, the program accepts an integer value. So this can be a scanf. Okay, you can work out what to put inside the scanf. Then we get to if the user does not enter a valid value. Now, my recommendation is that with this, you just use an if statement, which you'll see this week. And you'll notice that the program accepts an integer value and it asks this question over and over again. Okay, and you can see this in this example. Yes, you can see this video later. So you can see that it's repeating these operations. So here we've got if something print invalid. Okay. Now, the loop, if we have a look at it, there's two ways to implement it. We either loop what we've done before, because we're just printing that out again. We're just getting the user's value again, and we're doing the if they enter something invalid. So really what you can do is you can put all of this into a loop. Now, there is a slight optimization where you put the whole program into a loop, but while you're learning, this is good enough. And we'll talk about what loop next week. This is going to be either a while or a do while if you are reading ahead. Okay. From there, after that loop, okay, I haven't drawn it, then you'll go into the if it's a table 1 or table 2. Okay. And then you've got a bunch of printf, scanfs in a row. Printf, scanf, printf, scanf, and so on. And then you get to your hard part, which is going to be your for loop. Okay. So you'll be looking at loops this week in the lectures. So I don't want to start teaching that before you've covered it. But if you want a general structure or you're a little bit ahead, that's the general structure that we're following. Now, I haven't included everything, and obviously you can't, that's not code. But that'll give you a good way to start thinking about the problem. How many? Okay, so that's actually a really excellent question. How many variables should be initialized? So where should I show this? I'll do it in this example. And actually, this is a common problem. So for the start, we need somewhere to store the 1 and 2. So we know that we need these between these braces. So we're going to declare that right up here. Okay, so I might call that int choice. Now, it doesn't actually need to be initialized because I'm grabbing it off the user. But if you want to initialize it to 1 or 0 or something like that, that's fine. Now, one thing that I will mention. All right. So, all right. Let me answer questions as we go. Is there a need for a hash include math.h? No, definitely not. And as it says on the assignments, do not include anything else. There is absolutely no need for math.h in the assignment. Just in terms of the variables that should be initialized, there's only one at the start. We're going to create a couple more later on, and I'll explain why in a second. In terms of a switch, because it's a binary case, a switch is redundant. It's way more complexity for something that is a binary case. So a binary case just means on or off. Okay, it's a 1 or a 2. A switch is really over the top for a binary case. Some of you may have a ternary case. So you might have 3 options if you put the whole thing inside of a loop. I'd still say a case statement is probably a little over the top for that. But if you really want to use it and you're not using it for a binary case, I don't have too much of a problem with it, but it's probably not necessary. For this problem, like personally, I wouldn't use a switch at all. It's doesn't really have any advantage. And for the binary case, it has a disadvantage. So does that make sense? So pretty much for this subject, we don't really use switch that often anyway, is the other thing. So if you want to check if you're doing something right, use a if statement so that we can give you feedback, because most of the stuff will be if statements. All right, so now I'm going to go into something important, which a lot of students that have done a bit of C before do wrong, but the students that haven't do right. I'm just going to answer an email. So give me 5 minutes, and then we'll go talk about a really quick introduction to scope, because I noticed a lot of students. Yes. If you use a if else if, you can cover all three options, and really for this problem, that's a preferable way to go. The switch doesn't really add much. Usually you use switches for quite a lot of options. So I prefer to see an if and else if, or an if and else, because that's what we're going to use in the labs and the lectures and stuff like that. So I want to see if you're doing that right. But it's up to you. I'm just going to be back in 5 minutes. So I'm just going to answer an email. And yeah. Then I'm going to go over something important, which is where to declare your variables. Okay, because I noticed already some people doing this wrong. All right, I'll be back shortly. I'll just put this on mute. Someone will remind me when I get back. So if you use the don't stress, and really, you've got heaps of time. So if you can change it, it shows that you really understand it well. All right, I'll be right back. sound does help. I'm glad you're on top of that. There should be audio now, I hope. All right, so with what I was going to mention before was talking about where your variables are declared. And this is especially important for scientific computing when we have lots and lots of variables. And I'm not going to go through the reasons on how scope works too much right now. We can go through that later, but we can have a look at the practice of good scoping, and we'll look at even better scoping even later. But right now, basically, you're going to have an if and an else in your program. And with one if, you're going to have some variables that are only going to be used inside of this if. And within the else, you're going to have some variables that are only going to be used inside of the else. So if you know that your variable is not going to be used anywhere else, okay, or that it is a temporary variable, such as an iteration variable, such as I, j, or k, then they should only be declared, or another example is temp, or n, or m. Okay, I'll talk about some of these right now. I'll talk about these three in a second because I've noticed some people have done this wrong as well. So if you know that your variables are only going to be used within two braces, then they should be declared within those two braces. Okay, so don't declare everything right at the top. Rather, if I know that it's only going to be used in here, then declare it inside of here. This does a couple of things. The first thing it does is improves readability. The second thing it does is it improves automated test cases and also other people testing your code. It also ensures that you aren't using variables in places that you shouldn't be, and it will help with a lot of maths. So try and follow this practice. We'll go through what this does a bit later, but this is an important concept that if you start doing it now, it'll make it easier later. Okay, so if it's only used between a set of braces, try and declare it within those braces. Now, we haven't seen for loops yet, but if you are a little bit ahead and you are using for loops, professionally, if I see the variable name I will always assume that I'm in some one-dimensional problem, okay? And I is the iterator that's iterating over that one-dimensional problem, okay? So I've got something that's in a line, and this could be your values for your temperatures and stuff like that. Usually I wouldn't use it that way, but I'm happy for you to use it that way in this assignment. I will discuss a slightly more scientific, it's not as optimal, but it's more readable way of doing it. But the main point here is that in this assignment, everything is one-dimensional, okay? There's no two-dimensional problems in this assignment, so I shouldn't see J or K anywhere. If I see J, I will always assume that we're dealing with a two-dimensional problem. If I see K, I will always assume that we're dealing with a three-dimensional problem, and that I will also assume that I'm inside of a nested for loop. So those that are ahead, you shouldn't be using J or K because it's not that kind of problem. For those that aren't ahead, don't stress about this too much. Just keep in your mind that we don't really need J and K for this assignment. So that's just something to note, all right, for anyone that is ahead. What was I going to say? The other ones, if you have temporary variables, we will look at these a little bit later in some of the labs. Some variables you just need for a couple of lines. Sometimes we will purposely scope them so that they only exist until we get rid of them. What do you mean no audio? Is there no audio or is there audio? I'm so confused. I accidentally turned it off. Did I accidentally unplug something? No. Testing, testing. There's audio on my side. The person might be. Okay. You might be 5 minutes behind or something. Cool. Awesome. That's fine. That's fine. What was I going to say? Yeah, so sometimes we'll use temporary variables, and we might intentionally introduce more braces, which we'll talk about later. N and M usually refer to number of, and for two-dimensional problems, the second dimension size. So try and avoid using these unless you are using them for their purpose, because if we read them, we'll assume they are doing that task. The big thing here is just avoiding the J, because I've noticed a couple of people doing that. All right, so yeah, are there any other questions? Try to think if there's anything else covered that would be helpful starting on the assignment. With the assignment, also, once you do get up to step 4, if that's what you've got up to, just make sure it does actually print all this stuff out and just double check the password. Yeah, so the descriptive labels is good. So we generally avoid actually storing the temperature in I. We'd use it as an iteration variable, but for those that want to use it to store the values in this assignment, I'm not too stressed about. It's not that professional, but it's fine. Alternatively, yes, you can store the temperature in a descriptive label and then iterate over that. Usually these you'd consider inside of an array. So someone asked if we define common variables for both options. So there shouldn't be anything that's shared between the options. The iteration is going to be separate anyway. Those two variables are not dependent. And so they should be, let's say I've got I, int I should be declared here and int I should be declared here. For example, because they're not dependent variables. They're not dependent on each other. If they were dependent, then I would declare it up here, but they're not. Same with everything else. Everything else is not dependent on each other, so I don't need those values afterwards, and I don't need them before, so I declare them there. Sometimes this can be a little bit more complex if we do need the values later, or if I've got for loops in different locations. Sometimes we will do some little tricks to redeclare variables rather than reuse. But don't stress too much. If you have a good go at it and try and get into the practice of declaring variables in here, if you've got a couple of little mistakes, it's not going to make a huge problem. They shouldn't be the same because some are integers and some are floating point. And it says that you should need to use the appropriate types. So you need to use the appropriate types. Any other questions? Well, I just have a quick look at LMS, see if there's anything else that I've missed. LMS. Same with lectures. If there's anything from the lectures you don't understand, just mention the page number. Yep, so we're doing if this week and bitwise. Awesome. So, did I? No. All right. So next week's lab, we're going to do some bitwise operators. So next help session, I will do. No, we're not. Where's bitwise? Oh, it's not till week 5. That's okay. What else do I need for? I think that's really it, unless anyone has any questions. If there's anything that didn't make sense in the literals in different bases, I think that's. So there's 2 videos here. The typecasting one, we did a little bit of that today in the video, but to go into it in depth, I highly recommend you watch this. This one here is fairly self-explanatory, but if you do get stuck, just let me know in the student questions and we can probably add some more information to that. The different bases thing is based upon the number system bases, such as decimal, binary, and hexadecimal also. So you will need that pre-knowledge. There is a, so just to note also, this video here, Rick's going to cover this a lot later in the subject, but I find that a lot of students struggle with this because it's later in the subject and their mind is full of stuff. In the labs, I grouped various lines together. That doesn't matter. No, it doesn't matter. As long as it's readable, it's fine. So I find that students find doing this while they're doing other assignments for other subjects and learning a bunch of other stuff, it's difficult. So I put this up early, so you can go through it early, and the next video follows on from that. So the question that I was kind of half answering without repeating the question is, if you grouped various lines together, that's fine as long as it's still readable. So with any code, what you've got to remember is that the number of lines of code is not a measure of efficiency. We use other tools and other notations for efficiency and other metrics, but number of lines of code is never a metric for the optimization of your code. Rather, it's more a metric of your readability. So if you maintain readability, it's fine. And it's good to see if you can combine or simplify. Usually that's a good thing. Just as long as it's not destroying the readability of the code. Any other questions? So where are we? Okay, cool. Awesome. So hopefully that was a helpful session. As these weeks get harder, we can go through a lot more. But thank you very much for coming. shows that you really want to learn. And I was really happy with the chat because they were very talkative. So thank you very much. Unless there's any final last-minute questions, I might leave it there because we haven't covered enough yet. I'd usually go a little bit longer, but there's not much. We're only a week two, so there'll be plenty more to cover next time. And I'll probably do an extended one next time as well for the assignment. So thank you very much. Once the feedback comes at the end of the week, if you like the help session, just definitely mention it because I want to maintain it and keep it around. All right. I'll wait 5 minutes, and if there's no questions, then I'll leave it at that. Thank you for attending.